So in the same topic of quantum theory, electronic structure of atom, we are going to learn something on paramagnetism, diamagnetism, and these two depends on Hund's rule, which we have already learnt before. So revising on the Hund's rule, we know that Hund's rule states that empty orbitals are filled first, pairing occurs later. That's for in case of oxygen, the 1s2 and 2s2, the two electrons are filled in with opposite spin, but in case of P, it is the empty orbitals P, X, Y and Z gets filled one each, and the fourth electrons pairs up only after filling up the empty orbitals. Similarly, we have done it for other elements also. Chlorine, the empty orbital 3p5 will have 2 electrons in each, and then and 1 in the last one. So for iron also, the electronic configuration looks as shown. Diamagnetic and paramagnetic. Why did we start with Hund's rule again? Because there are certain elements, even if it has even number of electrons, some of the electrons can be unpaired. So the substances that have unpaired electrons, they are called as paramagnetic, and paramagnetism means they are attracted towards the magnetic field. And some of the examples are oxygen, nitrogen, copper. We know oxygen has got 8 electrons, but because of Hund's rule, it has unpaired electrons. And we have other kind of elements, they are called diamagnetic. So these are elements that has paired electrons. So and they are deflected away from the magnetic field, or in other words, they are repelled by a magnetic field. The examples of diamagnetic elements are calcium, argon, zinc, and or other words I can say that elements which belong to group 2A or the inert gases are the 2B. The zinc, the element that belongs to the zinc group, they'll all be diamagnetic because their electrons will be paired. Now let's do some questions on paramagnetic and diamagnetic elements. And the first example given is titanium. You have to predict whether it will be paramagnetic or diamagnetic. So write down the shell and put in the electrons, and when you see the box structure, you see that it has 2 unpaired electrons, hence it is paramagnetic. Next element given over there is selenium, and that also has 2 unpaired electrons, and therefore it will be paramagnetic. So what you need know from here is even number of electrons doesn't mean that it will be diamagnetic. But the next element, strontium, given has paired electrons, and hence it will be diamagnetic. So the element after that we have given you is cadmium. Cadmium will also have paired electrons. All the electrons in cadmium are paired, and cadmium will also be diamagnetic. So another example given over there is potassium. Potassium has got just 1 electron in the s orbital, and it will be paramagnetic. The last example, argon. You can see that all the electrons present in argon are paired up, and hence it is going to be diamagnetic. So we will do just one more question. Write down the number of unpaired electrons in the following. If you want, write the box structure and find out. But with experience, you can see that I can get the unpaired electrons just by writing the electronic configuration. As I have written, nickel has got 2 unpaired electrons, Fe2+, the 4s electron should have gone. And if you write down, expand the 3D, you will see that it will have 4 unpaired electrons. Manganese 5+, the final electronic configuration will be actually 3D2, and hence it will be 2 unpaired electrons. And rubidium plus will not have any unpaired electrons. And copper will have 1 unpaired electrons, and rhenium RH will have 3 unpaired electrons. And chromium, we know that the electronic configuration of chromium will be 4s1 3d5, and therefore it will have 6 unpaired electrons.